Hello everybody, I am Kiran Kumar from Nature of Physics. Today topic is orbital velocity or orbital speed of the satellite in its orbit, student. The satellite is revolving around the planet. The planet is taken as Earth. Okay, small m represent the mass of the planet, capital M represent the mass of the Earth, small m mass of the satellite. And height of the satellite from the surface of the earth is small h. See there, small h represent height of the satellite from the surface of the earth, and capital R represent the radius of the earth from the center to the surface taken as radius of the earth. Okay, and v naught represent the velocity of the satellite is moving in anti-clockwise direction with angular velocity omega and linear velocity v naught, student. In this derivation we need linear velocity v naught considering. Okay, and on the satellite two type of force is acting. See there, one is centripetal force, okay, and toward the center, and away is centrifugal force, student. Centripetal force both are equal in magnitude, opposite in direction. So centrifugal force Fc, which is equal to mv naught square divided by small r, considering small r is equal capital R plus h. See student, small r is the distance from the center of the earth to the position of the planet. Okay, this is representing small r. Small r is equal to r plus h. See, from the center to the surface distance is r. From the surface to the satellite distance is h, that is representing height. See, clearly represented in the diagram. Okay, now I am going to discuss about the definition. After that, step by step derivation and conclusion we will discuss. Okay, so first one is definition. So this is important for the IP exam, for board exam. Okay, AP and Telangana student. So that the speed of the satellite in its orbit is called orbital speed. Once again repeating, the speed of the satellite in its orbit is called orbital speed, student. The velocity with which a body is projected, then the body is revolve around the planet in a circular orbit, the minimum velocity is also called orbital velocity. Okay, simple definition is written here. Next, the necessary centripetal force is provided by the gravitational force of attraction on the satellite by the earth, student. Okay, so here the satellite is revolving around the earth at a height h from the surface of the earth. So the revolving satellite have the centripetal force. The necessary centripetal force is provided by what, student? Gravitational force of attraction between the satellite and the earth. There is a gravitational force of attraction is takes place. The gravitational force is provide the necessary centripetal force, clearly written, and condition also writing now, that is Fc, which is equal to gravitational force, writing F, student. Okay, both are equal in magnitude, opposite in direction. Here gravitational force acting toward the center of the earth, and centrifugal force is acting away on the satellite of mass small m. Okay, student, so that the values are replacing step by step. See student here, so Fc is already written there, mv naught square divided by small r, which is equal to gravitational force basic formula G capital M small m divided by r square, student. So notice that here r and r square is get cancel. Then continuation step is, that is small m also get cancel both sides, and v naught square, which is equal to G capital M divided by r. G represent universal gravitational constant, capital G. Okay, student. Then v naught, which is equal to root over gm divided by small r. This I got as equation number 1, student. And continuation step, next I am replacing the small r value. Small r already written here, r plus h v naught, which is equal to root over gm divided by r plus h. And in this, one condition is there, student, that is r is very much greater than to the h, or r is greater than to h, simply writing, student. So what is negligible here? H is negligible. H is okay, student. So that v naught, which is equal to root over gm divided by denominator capital R. And we know very well one of the equation, that is relation between small g and capital G relation. So small g is the acceleration due to gravity, which is equal to capital G into capital M divided by r square. There is a possibility to get that relation in this above equation. Now I can write this is equation number 2, student. In this equation, r multiplying and dividing in the next step. See, student, v naught, which is equal to g capital M divided by r is there, student. I am doing here r multiplying and r dividing simply for above equation. So that continuation equation, v naught, which is equal to orbital velocity, okay, root over gm divided by denominator r into r is r square, student, into r, writing numerator as usually. Okay, now small g we can replace in the above equation. Okay, so that we will get v naught, which is equal to root over g capital M divided by r square, one more step writing, student, into r. So the value is replacing now here. So that v naught, which is equal to root over g into r. Okay, student. So that I can write this is equation number 3, clearly given. And continuation, we can replace the values. We will get the orbital velocity also. G is the acceleration due to gravity, that is 9.8 meter per second square. R is writing approximately radius of earth is 6400 kilometers. Then we will get the orbital velocity v naught, which is equal to 7.92 kilometer per second, student, kilometer per second. Okay, this is clear information about the orbital velocity of the satellite. Please do like and subscribe our channel Nature of Physics.